So the secret to getting good at these proofs, trig identities, these are often pretty challenging for people when they're first starting out, and even people that have been doing it for a while can be challenging. The secret is just doing a lot of them. The more of these you do, it's really a case of practice makes perfect. The other thing to understand with proving trig identities, and again, what we're trying to do is prove that the left-hand side, LHS stands for left-hand side, of any identity is equal to the right-hand side. Like this is a left-hand side, that's the right-hand side. We proved that in an earlier video. The trick is that there's no formula for this. It's not like solving a quadratic equation where you just get your numbers and plug them in. All we have are general strategies. It's like solving a puzzle. You can't use the same strategy to solve every puzzle because every puzzle is different. You just use some general strategies. So here are the four main strategies we'll use for proving these identities. Like I said, we'll do a bunch of examples in separate videos. The very first thing we have to do is always start by picking the more complicated side. So if you look at number 1, for example, number 1 they're about equally complicated, but number 2, this is that side is definitely more complicated than the right side. So we'll pick that and we'll start by that. The reason being is that it's easier to take something complicated and simplify it than to go and take something simple and mess it up in just the right way. So for example, it's easy to change sine squared plus cosine squared to 1. It would be really hard to look at the number 1 and somehow know that that was sine squared plus cosine squared. Okay, strategy number 2 is we'll try to make one of these Pythagorean identities appear whenever possible. And how will we know when they're occurring? We'll know if we see anything being squared. Because notice every single one of these has a term in it that's being squared. So if you see a term being squared, what I want you to think of is that's probably a Pythagorean identity. Or it might be some version of it. So for example, if you took this identity and you subtracted sine squared from both sides, you would have this. Or if you subtracted cosine squared, you have this. Strategy 3 is we'll use all the normal algebra techniques we're used to using, so things like factoring or using the conjugate, and we'll try to show you an example of those in a couple videos from now. Okay, and then if you really get stuck and you try changing the left side and it's just not working, you could go over to the right side and start changing that. And if you can make them meet in the middle, then that's enough to prove it. Like if I get stuck on the left side and I just start changing, I'll show you an example of that in a couple videos. As long as we make them meet in the middle, we've done what we needed to do. And then the last principle is this: if you're ever really stuck, make this your last step though. Don't go straight to this. When you're really stuck and you don't know what to do, change everything into sines and cosines. And the reason you can do that is because all of these functions up here are expressed in terms of sines and cosines. This is cosine over sine, and tangent is sine over cosine. We write it horizontal instead. So let's use these strategies to start proving identities. Okay. So this one right here, number 1, we have to start by picking the more complicated side. They both look kind of complicated, so let's not really pick. Let's just kind of do both of them. Maybe we can use this strategy, make them meet in the middle. Okay, the other thing, strategy 2, try to make well-known identities, and well-known especially means Pythagorean identities. And I see a way to do that because sec squared has this as a Pythagorean identity. So I'm going to replace sec squared with tan squared plus 1. Why would you do that? Because if you look at the right side, there's a tan squared. So we know that we want tan squared to appear on that side. Okay, and then we have cosec squared. Actually, this should be x's instead of theta. Okay. All right, so it's not entirely clear how we're going to make it equal the left side just yet, but we'll keep going here. So try to make well-known identities appear. Let's see if we can make something meet in the middle. Let's use another Pythagorean identity, okay? Because strategy 2 says try to make well-known identities appear. We've chosen to manipulate the left-hand side. Here's another identity. Cosec squared has 1 plus cotan squared as its identity. So I'm going to replace cosec squared, which is this right here. I'm going to replace that with, and it's minus by the way, so we have to put that in parentheses. I'm going to replace that with 1 plus cotan squared. Okay. And actually, when we're doing the identities, we shouldn't write that right side because in most cases, we're only going to be touching one side. So we'll leave the right-hand side alone. Okay, now if we distribute this minus, we'll have tan squared of x plus 1 minus 1. And actually, that minus is going to get distributed to the positive right there. So you'll have minus cotan squared x. And now we're pretty much done because 1 minus 1 is 0. So look what we're left with, tan squared minus cosine squared. That's how we prove an identity. We show that the left-hand side turns out to be identical to the right-hand side. See if you can pause the video and try to use those 4 strategies to do number 2 right here. All right, so number 2 says the following. I'm going to move this over here so we can have it in our frame of reference when we're doing this right here. Okay, always begin with the more complicated side. I think the left-hand side is slightly more complicated here because there's just more things on it. Try to make well-known identities appear. Here is a well-known identity. That's a Pythagorean identity. That's this right here. 1 plus cotan squared is the same as cosec squared. So I'm going to write it like that. Okay, and actually I keep doing theta out of habit, but these should be x's because that's what they gave us. Okay, so we made a well-known identity appear. Now what should we do? Okay, well, I don't see any more well-known identities. When in doubt, and this is where this one comes in, when in doubt, change everything to sines and cosines. So let's do that. Cosecant is the same as 1 over sine. So cosec squared would be like 1 over sine squared. And then let me make a big red fraction bar so you can see this is different. That red one is same as the red one on the other. The bottom is the same, secant is the same as 1 over cosine. So now we have a fraction over another fraction. Now we use normal algebra techniques. In algebra, how do you normally divide a fraction by a fraction? The acronym that I sometimes use is copy dot flop or copy dot flip. You copy the first fraction, you make a dot for multiplying, and then you flip, you multiply by the reciprocal of that, which is cosine over 1. Okay, so we're almost there. So now let's change this around. We're going to have cosine over sine squared. Okay, cosine over sine squared. So now it would be a good idea to see what are we actually trying to prove. We're trying to prove cosecant over tangent. Okay, tangent is the same though as sine over cosine. So I know that I want a sine over cosine on the bottom here. So this would actually be a very good problem of this strategy where you want to make them meet in the middle. So let's do that. We're a little bit stuck right now, so let's pause and let's now start working on the right-hand side and see if we can make it meet in the middle with cosine over sine squared. That's what we'll try. So I'm just going to copy that over here. So this, we're now starting to work on the right-hand side. And the right-hand side, once again, it was cosec over tan. So we want to start changing that around and see if we can make it meet the other one in the middle. So we're gonna play with the right-hand side now. When in doubt, so I don't see any Pythagorean identities. When in doubt, change everything to sines and cosines. This is the same as 1 over sine. And then we'll make a big red fraction bar to show that. Okay, the bottom is the same, tangent is the same as sine over cosine. And now we can use our same strategy, copy dot flop. So we're going to copy 1 over sine, make a dot for multiplying, and then flop, so we get cosine over sine. And now we made the meet in the middle, because see what happens now. Cosine times 1 is cosine. Sine times sine is sine squared. Now all I'm going to do is box that off. I'm going to box that off and show that we made the meet in the middle. So the left-hand side is equal to the right-hand side. That is how we prove a trig identity.